In this video, I want to talk about bonds. So let's start with the million-dollar question. What is a bond? So a bond is a long-term loan given to a company or government. So companies, IBM, Apple, Amazon, issue bonds. Governments issue bonds. The US government issues bonds. Japan issues bonds. China issues bonds, and so on. When those companies or governments issue bonds, they sell them to the public. Those are called investors or bondholders. Those bondholders give the money to the company and government in exchange for those issuers of the bonds promising to make the bondholders a series of coupon payments and then a face value payment at the end. Okay? Let's look at an example. Suppose IBM issues a 3-year, 10% coupon bond with a par value of $1,000 and annual coupons, and you're considering purchasing the bond. Okay, the big question is, what is IBM promising to pay you if you indeed purchase the bond? Okay, let's go over to the glassboard and take a look. In the old days, a bond, in our example, used to be a piece of paper. And that piece of paper used to have all those contractual obligations on it. So it looked like this. Imagine IBM issued a bond. This nice big piece of paper. It would specify the face value or par value. Those are synonyms. Let's say of $1,000, as in our example. It would specify the maturity date, maturity date, in our example, 3 years from now. Okay. It would specify the number of times payments are made per year. We're told in this example annual coupons. So the number of payments per year, 1. Okay. And it would specify a coupon rate. Okay. In our example, 10%. So in the olden days, you used to get a piece of paper like this. Today, everything is digital, so no more pieces of paper. But that piece of paper is relevant because it has all the contractual features on it. So what is a piece of paper, a bond like this? What promises is this bond or the issuer of the bond making? What it's saying is the following. Between now and 3 years from now, I promise to pay 10% of the face value per year. So between now and 3 years, I promise to pay 10% of the face value per year. Okay. How many payments am I going to make per year to pay out that 10%? 1. So quick calculation. Okay, that means between now and 3 years from now, I'm going to make annual payments of $100 each year. 100 year 1, 100 year 2, 100 year 3. Okay? And then finally, at the very end of those payments, right after I make that last $100 payment in 3 years, I'm going to pay the big face value amount of $1,000. Okay, so when IBM issues a bond like this with this series of promises, it's essentially promising the following stream of cash flows. Imagine we're starting here at time 0. Okay. At time 1, a promise of $100 is made. 10% of the 1,000. If this was number of payments per year 2, that would be in 6 months, $50 would be paid. Does that make sense? Okay. But it said annual coupon, so 1 year from now, $100 is paid. Okay. 2 years from now, what's going to be paid? Another $100. Okay. 3 years from now, what's going to be paid? Another $100 plus the big face value payment at the end because we've reached maturity. So 100 plus 1,000, so that's a total of 1,100. So stepping back, if you received this bond from IBM, okay, you're holding this bond, you're the bondholder, you're entitled to the following stream of cash flows. IBM is promising to pay you the following stream of cash flows. $100 in 1 year, another $100 in year 2, and $1,100 in year 3. Okay? All right, back to our slides. All right, so what were some key terms in that IBM example? Well, we need to know what the par value is, or face value. So the par value or face value is that big lump sum payment which is made at the end. Typically, this is $1,000 per bond. Okay. We need to know what the coupon is. This is the percentage of the par value that is paid every year. Remember, in our example, it was 10%. That par value or face value is $1,000 in our example. The coupon rate was 10%. That means IBM is promising to pay 10% of $1,000, which is $100 every year. Now, if coupons are paid annually, it's just the $100. Most coupons are paid semi-annually. And so like in our example, that $100 would have been split into 2 6-month periods. And so IBM would be promising to pay $50 every 6 months if coupons were paid semi-annually. And then finally, maturity. Maturity is the amount of time that passes until that par value, that face value payment, that big lump sum payment is made at the end. Okay. What's the value of a bond? Well, the economic value of the bond is just the present value of its cash flows. We can apply value additivity in our single cash flow formula and get exactly the formula for the value of a bond. So the value of the bond V, you can see on the left-hand side, is just the first cash flow discounted back to today, plus the second cash flow discounted back to today, plus the third, so on and so forth, all the way out to cash flow N discounted back to today. So looking at that formula, you can see there are 3 kinds of information that are required to figure out the value of the bond. You need to know how big the cash flows are, what those CF1, CF2, CF3, all the way to CFN, what those values are. Okay. The timing of them, when they arrive, 1 year from now, 6 months from now, 2 years from now, right? The timing of their arrival. Okay. And then finally, the discount rate. What the R or R's, we're going to see they can be different R's later in this video. What the R's are that discount each of these cash flows back to today. Okay, so those are the core components in bond valuation. All right, let's talk about types of bonds. They're interest-only bonds that pay regular coupon payments throughout and then the big lump sum principal payment at the end. Most corporate bonds are interest-only bonds. There are 0 coupon bonds, which are what they sound like. The coupon rate is identically 0%, which means no coupon payments are paid throughout the life of the bond. Just the big lump sum payment is paid at the end. So no coupon payments, just the big face value or par value or lump sum value at the end. Okay, and then for personal borrowing, like your car loan, your home loan, those are called level payment loans where you pay a constant amount all the way through maturity. Okay, there's no big lump sum at the end, right? When you make your car payment, you pay the same amount for the life of the car's loan, right? 5 years, 7 years, however long it is, you're paying the same amount. It's not like at the right when you make the last car payment, they say, all right, now give us $10,000, right? There's no big lump sum payment at the end, right? It's a constant level payment throughout the term of the loan. Okay? Again, most car loans, home loans for personal borrowing are level payment loans. All right, let's jump back into our IBM example. So consider again the 3-year 10% coupon bond that had that par value of $1,000. And let's say the discount rate for similar bonds, so bonds that have a similar level of riskiness to them, is 8%. All right. The question is, what price are you willing to pay for the bond? Okay, let's jump into the slide. Well, using what we just said, hey, what are we going to do? We're going to take each cash flow 1, cash flow 2, cash flow 3. Remember our glass board work. This is 100, 100, 1100. Okay? And we're going to discount each of those cash flows back to today. We're told that the discount rate is 8%. So the R I'm going to use for each of these cash flows is 8%. So fill in 8% here, right? Okay. And we get what? We get the first cash flow has a present value of $92.59 when we discount it back to today. The second cash flow has a present value of $85.73 when we discount it back to today. And that $1,100 cash flow 3 years from now has a value of $873.21 today. Add them all together, aka apply value additivity, and we get an economic value of the bond of $1051.54. Okay. And then the bottom of the slide said, what happens to value when discount rates increase? Okay, so let's do this calculation and answer that question in Excel. So I'm going to jump over to Excel. And I am on the first slide tab. So this has the inputs to our problem. The par value or face value is 1,000, matures in 3 years. The coupon rate is 10%. Payments per year 1. The discount rate 8%. Okay, so hopefully everyone's comfortable with this stream of cash flows: 100 at time 1, 100 at time 2, 1,100 at time 3. Okay. All right, how would we calculate the present value of each? It was on the slide, but I'll replicate it here. We take each payment and discount it back to today. So the first 100, I'm going to divide by 1 plus the discount rate, which I am going to freeze with my $sign so it doesn't move when I fill across, to the how many periods am I going to discount it back? 1. Okay, it arrives 1 period from now, this 100. Hit enter. It's worth $92.59 today. That's its present value. Fill across, we get the present value of each of these 3. Sum together, $1051.54, which is exactly what I got on the slide. Okay? All right. Alternatively, I could have done it in one fell swoop. I could have just used the PV function. Think about it. I know my discount rate is 8%. I know the number of periods, 1, 2, 3, is 3. Could also just put in the maturity. Okay. The payment each period is 100. Formulaically, 10% times the 1,000. And then remember, I can put in that big FV. In this context, think of this as the face value, right? That big lump sum payment at the end is the 1,000. Close parentheses, and I get the same $1051.54. Okay. So 2 paths to exactly the bond's economic value, $1051.54. Okay. So question, what happens when discount rates increase? Well, before I show you, think about the single cash flow formula. When a discount rate goes up, when that denominator, that 1 plus r to the power n, when r goes up, you're going to be punishing future cash flows more, right? When you go from future cash flow to present value, that future cash flow is going to be discounted more heavily, right? So let's see that. So when I increase this discount rate, we should expect this bond price to fall. Let's see it. Let's make this discount rate 10%, and we should see the bond price go down. Indeed, it does. How about if we made it 15%? Should fall even more. Okay. So as discount rates go up, or as interest rates go up, bond prices come down. Good. Let's jump back to our slides. All right, let's say you wanted to own a bond. So you went bond shopping. Okay? There's something you would notice. When shopping for bonds, you would notice that the interest rate is different for short-term bonds than long-term bonds. The interest rate is different, even if the riskiness of the bond is the same. So this leads to an important definition. The term structure of interest rates, also called the yield curve. The term structure is the set of interest rates for various maturities for a particular risk class of bonds. So why might interest rates vary across maturities? Why would the interest rate for the 1-year bond be different than the interest rate for the 30-year bond? Well, here are a few reasons. First, it could be tied to market expectations. If the market believes, for example, interest rates in the future will be higher, then the interest rates for long-dated bonds, bonds that mature way in the future, will also be higher. Okay? You can get lower prices for longer maturities because they are viewed as riskier from an interest rate point of view. So for example, imagine a short-term bond, a bond that matures in 6 months. If the interest rate changes a little bit, it's not going to affect that single cash flow that you're going to get in 6 months. It's going to have a very small effect on it. Compared to a bond that has lots of payments left way out in the future. Okay? Those payments way out in the future are very sensitive to small changes in the R, in the discount rate. Okay? So long-dated bonds have more interest rate risk. If they have more interest rate risk, if they're viewed as more risky from the bondholder's point of view, well, they're going to sell for lower prices, aka have higher interest rates. And then finally, you can get variation in interest rates across maturities just from supply. Okay, so if there's a larger supply of short-term loans versus long-term loans, for example. Okay, in general, though, the important takeaway from thinking about a term structure of interest rates is that there is no single discount rate for a series of future cash flows. There's nothing that says the discount rate for the cash flow 1 period from now, 2, 3, 4, 5, 6, has to be the same. Okay? Let's take a look at the slide. So to be precise in computing the present value of future cash flows, we can use the interest rate for the date of that cash flow. So for example, for a cash flow that arrives at period 1, so CF1 here, we can use an R1, a specific interest rate for that cash flow arriving at time 1. For CF2, the cash flow that arrives at time 2, we can use R2. Okay. The important departure here is that R1 need not be equal to R2, right? They need not be the same. Heretofore, what we've been doing is assuming all those discount rates were the same. R1 was equal to R2, R3, and so on. We need not do that. Okay? The discount rates can be different at different points in time. Okay. When we take each of these discount rates, R1, R2, R3, R4, by the way, these are called spot rates. R1 is the 1 period spot rate. R2 is the 2 period spot rate, so on and so forth. When we take each of these spot rates and plot them on a graph, okay, that graph is called the term structure of interest rates, aka yield curve. Okay? Let's look at an example. Suppose the yield curve is given below. Okay? So think about how to interpret this. So here we have years. 1 year, 2 year, 3 year. So what does this say? The 1 year spot rate is 1%. The 2 year spot rate is 2%. The 3 year spot rate is 2.5%. Okay? So the 1 year spot rate of 1%, the 2 year spot rate of 2%, the 3 year spot rate of 2.5%, plot them on a graph, and we get a yield curve. This is called a yield curve or term structure of interest rates. Okay. So if we were given this yield curve, what should the price of a 2 year, $1,000 par, 3% coupon bond be with annual coupons, where the next coupon is due in 1 year? Let's price that bond. And then let's price, how about a 3 year, 1% coupon bond? Let's also price that bond. Let's jump to Excel and do it. So I'm on the next slide. All right. And this next slide has the important components to the problem. So remember, the problem tells us that the 1-year spot rate is 1%, the 2-year spot rate is 2%, and the 3-year spot rate is 2.5%. Okay? And bond 1, remember, has a coupon rate of 3%, a par value of 1,000, and matures in 2 years. Okay? So first, let's think about the timing of the cash flows. A bond that has a 3% coupon rate, a par value of 1,000, and matures in 2 years, let's think about what those cash flows look like. Here's time 0. 1 year from now, we're going to get 3% times the par value, that's 30 bucks. 2 years from now, same thing, plus that big lump sum value of 1,000 at the end. So hopefully it makes sense that the stream of payments will be 30 at time 1 and then 1,030 at time 2. So hopefully that stream of payments makes sense. Okay. To find the bond price, we need to discount those cash flows back to today. So the first one, the $30 one, okay, I'm going to discount it back to today. Now here's where it gets interesting. Before, I just had one discount rate, right? In the Excel spreadsheet, I have something like discount rate or interest rate, and I would just use it. But now I need to match the spot rate to this cash flow. This cash flow arrives at time 1, so I need to discount it by the time 1 spot rate, which is 1%. Does that make sense? This cash flow arrives at year 1. We have a year 1 spot rate. The year 1 spot rate is the appropriate discount rate for cash flows that arrive 1 year from now. Definition, that's exactly what the 1-year spot rate is. All right? So discount that 30 back to today at the 1-year spot rate, $29.70. This 1,030, which arrives 2 years from now, you guessed it, I'm going to discount it at the 2-year spot rate. Let's go find that. The 2-year spot rate is 2% here. Okay, discount it back 2 periods. It arrives 2 periods from now. I get $9.90. So this bond's price is just the sum of these two present values. Again, let's underscore what is going on that's different here. Before, we've had a single discount rate for a problem. Now I have different discount rates for cash flows that arrive at different points in time. For the 1-year cash flow, I have the 1-year spot rate. For the 2-year cash flow, I have the 2-year spot rate, and so on. Okay, that's the important innovation which is happening here. All right, let's price the second bond. Okay, the second bond has a coupon rate of 1%, okay, and its par value is $1,000. Okay. Think about what a coupon rate of 1% and a par value of 1,000 is going to create. It's going to create the following series of cash flows. 10 at time 1, 10 at time 2, and 1,010 at time 3 because that's when the bond matures, 3 years from now. So each year you get the 10 coupon, the 10 coupon, the 10 coupon, and then the big lump sum of 1,000, so 1,010 at the end. All right, let's discount each of these cash flows, importantly, by their appropriate spot rate. So the 1-year cash flow of 10 gets discounted by the 1-year spot rate here. Okay, and we discount it back 1 period. The 2-year cash flow gets discounted by the 2-year spot rate here. Good. And the 3-year cash flow gets discounted at the 3-year spot rate here, discounted back 3 periods. Okay, so here's the present value of each individual cash flow discounted at its appropriate discount rate. Sum these together, and we get the bond price for the second bond, $957.40. All right, back to our slides. So here's another really important definition, yield to maturity. So definition. A yield to maturity is the single interest rate that implies a present value of cash flows of a bond that equals its current price. It's the single interest rate that implies a present value of cash flows of a bond that equals its current price. It will make more sense in the context of an example. So let's take a look at one. So let's reconsider the previous example, but with a different term structure and coupon rate. So imagine the following term structure. Okay. We have R1, so the 1-year spot rate is 7.8%. The 2-year spot rate is 8%. The 3-year spot rate is 8.2%. Let's say the coupon rate is 10% and the face value is $1,000. Okay. Well, we now know the value of the bond is computed by discounting each cash flow by its appropriate discount rate, by its matched spot rate, right? So we know a 3-year $1,000 face value, 10% coupon rate bond gives us this series of cash flows. 100, 100, and then 1,100, okay? Hopefully we're getting good at this. Okay, yeah, 10% coupon, face value of 1,000, matures in 3 years. That's gonna be 100, 100, 1,100. Good. All right, and then each cash flow we're going to discount by the appropriate spot rate. So this 100 here, it's going to be discounted by R1, 7.8%. See that matches here? The second 100 is going to be discounted by R2. And then the third, the 1,100, remember that's the cash flow 3 years from now, is going to be discounted at 8.2%, right, with an R of 8.2%. So 1 plus R to the third power, where that R is 8.2%. Okay? So this is review. This we've done in the previous slides. Okay? And when you do that, you get, take my word for it, a value for the bond of 1046.87. Okay? All right, so what is the yield to maturity? Okay? The yield to maturity is the following. Imagine we took this 1046.87 as given for the PV here. Okay? We know our cash flows, 100, 100, and 1,100. Here, CF1, CF2, CF3. The yield to maturity is the identical rate. What rate R could we put there in the denominator, which is the same at time 1, time 2, and time 3? What identical rate at time 1, time 2, and time 3 delivers this PV of 1046.87? That's what the yield to maturity is. Okay. Now, in this case, it turns out to be 8.176%. Okay? So this identical discount rate, identical across the maturities, time 1, time 2, time 3, if each of those R's was 8.176%, that would deliver exactly the bond price that we got up here. Okay. Now notice, you can see right off the bat, this 8.176% is going to be some weighted average of our spot rates, right? 8.176% is some weighted average of 7.8%, 8%, and 8.2%, right? All right, let me show you how we get it in Excel. So back to Excel. Next slide. Okay. So here I've done the math that you just saw on the previous slide. Okay? To get this bond price here, okay, this 1046 and change. Okay? But I want to calculate the yield to maturity. Well, let's think about it. So how can we calculate the yield to maturity? Well, remember, we can use the rate function. Remember, the rate function solves for the R in the annuity present value formula. And remember, Excel allows in that annuity present value calculation for a lump sum payment at the end, right? For a big face value payment at the end. Okay? So let's think about what would the inputs be to the rate function. Well, first, the number of periods. So the annuity, that $100 that's being paid, how many periods is it being paid for? 3. Okay. What is the payment per period? 100. Okay, so you can just grab any of the hundreds you want. What is the PV? Okay. The PV is this bond price. Okay, here. Now, here's where it becomes important to remember and obey the sign convention. If we're receiving these payments in the future, we need to pay out the PV today. So I need to make this negative. So I'm going to put 0 minus this bond price. If you don't do this, you're going to get an error or infinite message here. Okay? You have to obey the sign convention. Excel, remember, says if you're receiving money in the future positive, you got to pay it out today, PV. Okay. So I'm going to make that negative following the sign convention. And then the big lump sum payment. So I've told Excel about the $100 payments, right, each year for 3 years. And then now I need to tell Excel about the big lump sum payment, the 1,000 at the end. The yield to maturity is the R, which solves for that stream of cash flows that I told Excel, which is exactly the stream that we saw in the previous slide. And there's the 8.175%. Okay. Which matches what I got here, subject to rounding. Okay, I rounded here. The Excel calculation is the precise one. All right, some important facts about yield to maturity. So as I mentioned before, in general, the yield to maturity is a complicated average of the interest rates in the term structure, those series of spot rates. Okay. The yield to maturity is not a market rate of interest. Okay. Oftentimes, rather than quoting a bond price, a yield to maturity is quoted instead. So there is a one-to-one mapping between bond price and yield to maturity. You give me the bond price, like we saw in the last example, I can give you the yield to maturity. You give me the yield to maturity, I can give you the bond price. It's important to remember, though, that yield to maturity does not determine prices. Rather, yield to maturity is implied by a bond's price and its pattern of cash flows. Prices are determined by the market rates of interest, aka the spot rates, that make up the term structure. The yield to maturity is just an easy way to summarize the average rate of discount for a bond with multiple cash flows. Okay. Now, what if we can't observe the bond's market price in practice? Well, in this case, we can use the yield to maturity of a similar bond. If you sell the bond before maturity, there is no reason to believe that the return you actually earn from buying and selling the bond will be the yield to maturity. And then finally, the yield to maturity on a bond shouldn't be confused with the current yield, which is simply the total annual coupon payments divided by the current bond price. So in the previous example, that would be what? Well, that would be if I'm standing at time 0, okay, I'm going to receive $100 in the next year, remember? And my bond price was $1046.87. The current yield is just 1 divided by the other, so in this case, 9.55%. So don't confuse yield to maturity with current yield. All right, some more important bond terms to know. So these are the terms premium, discount, and at par. So if the bond price that you observe is greater than the par value, aka face value, then we say the bond is trading at a premium. If the bond price is less than the par value, then we say the bond is trading at a discount. And if the bond price is equal to the par value, we say the bond is trading at par. Okay. Now, there's an important relationship between the coupon rate and the yield to maturity and premium, discount, and at par. Let's take a look at it in Excel. So I'm on the next tab. Okay. So consider the following 3-year annual coupon bond. The par value is 1,000, the coupon rate is 15%, and the yield to maturity is 10%. Okay? So remember, the yield to maturity is, if I use this as the discount rate, I get the bond price, right? There's a one-to-one mapping, as we've said, between yield to maturity and bond price. Okay? Well, I've laid out the payments for you if the coupon rate is 15%. So it would be 150, 150, 1150. I've calculated the present value using the yield to maturity and summed them together to get the bond price. Okay? Now, what I want you to see is the following. What happens, so right now, the coupon rate of 15% is above the yield to maturity of 10%. Okay? Coupon rate above yield to maturity, and the bond is trading at a premium. Okay? A premium to par. Remember, this 1124.34 is above the par value of 1,000. Okay. Let's see what happens when I increase the coupon rate. Okay. If I increase the coupon rate, let's say to 18%, okay, what's going to happen to the bond price? Before you see it, let's think about it. If I keep increasing the coupon rate, I'm providing more cash flow per period. So the bond price, all else equal, should go up. Someone who is buying this bond is willing to pay more because more cash flow is being promised to him or her. Indeed, the bond went up, bond price went up even more. It's now trading at an even higher premium to par. Okay? All right, let's see what happens when I take the coupon down. All right? And specifically, let's take the coupon rate below the yield to maturity. So the yield to maturity is 10%. Okay? Let's take the coupon rate to 5%. And what do you know? The bond price now dips below the par value of 1,000. So now the bond is trading at a discount to par. And you can see if we pick coupon rates, let's pick a coupon rate of 8%. We can pick a coupon rate of 3%, right? As long as I, whoops, wrong one. Yield to maturity is 10. Let's put that back. All right, so let's pick a coupon rate of 3%. As long as I'm picking coupon rates below the yield to maturity, the bond will trade at a discount. Now, I think you can see where this is going. What if I pick a coupon rate equal to the yield to maturity? Okay, so it's equal to 10%. I'm going to get a bond price which is exactly at par. So let's summarize. When the coupon rate is greater than the yield to maturity, the bond trades at a premium to par. When the coupon rate is equal to the yield to maturity, it trades at par. And when the coupon rate is less than the yield to maturity, it trades at a discount. Okay. So that's the important relationship between coupon rates and yield to maturity. Coupon rate above yield to maturity, the bond trades at a premium to par. You'll find a bond price which is above the par value. Coupon rate equal to yield to maturity, it will trade at exactly the par value, in this case 1,000. Okay. Coupon rate less than yield to maturity, it trades at a discount to par. The bond price will be below the par value. Good. Back to our slides. All right, so let's just sum up what we've learned so far. The economic value of a bond is just the present value of its cash flows. We can take what we learned at the very beginning of this course, right? Value additivity and the single cash flow formula, and apply it to bond pricing. Okay. The economic value of the bond is just the present value of the future cash flow. So that implies three kinds of information are necessary to value the bond. Number one, what are the cash flows? How big are they? Number two, when do they arrive? And number three, what's the appropriate discount rate for those cash flows? Okay. And then let's fill in the following. We've seen this a couple times throughout this video. Bond prices what when interest rates rise? Well, when the R's, the discount rates, go up, bond prices fall. This is like an investment banking interview question. Interview question 101 in investment banking. Fill in the blank. Bond prices what when interest rates rise? Bond prices fall. Conversely, bond prices what when interest rates fall? Well, when the R's go down, bond prices rise. Okay. Good. All right, the next thing I want to do is discuss in more detail a bond type we introduced a few slides ago, a zero coupon bond. Remind yourself what that is. That's a bond that just makes one payment, just that payment at maturity, just that lump sum payment at maturity. We're going to see that zero coupon bonds are particularly useful in pricing more complicated bonds, the coupon bonds. So what I want to do is jump over to the glassboard and illustrate this for you, show you how we can use zero coupon bonds to price more complicated bonds like coupon bonds. All right, so let's think back to that bond we discussed a few minutes ago. So remember this bond. We had a coupon bond. It had a face value of $1,000. It had a coupon rate of 10%. It had a maturity in 3 years. Okay? And the number of payments per year was 1. So we had annual coupons. So remember this bond. Okay. Remember we said this bond creates the following stream of cash flows, right? So we're standing at time 0. At time 1, this bond will pay out $100. Remind yourself how we did this. The coupon rate of 10% times the face value of $1,000. It just makes one payment per year, so that's, bam, just $100 per year. That same $100 will arrive at time 2. Okay? And then at time 3, there will be what? $1,100. Why $1,100? It's the 10% times 1,000, that's the same 100 coupon payment every year, plus the big lump sum face value payment at the end, $1,100. Okay. So we know this coupon bond, right, in the old days, this piece of paper would throw off this stream of payments, 100, 100, 1,100. Okay. The insight with respect to zero coupon bonds is the following. Let's think about this $100 payment standing here at time 1. We can think of this $100 payment at time 1 as a zero coupon bond that has a face value of $100. Okay? Obviously, it's zero coupon, so the coupon rate is 0%, and it matures in 1 year, right? So this $100 payment is identical to a 0 coupon bond with a face value of 100, a coupon rate of 0%, that's what 0 coupon means, that matures in 1 year. Okay? This next $100 payment here at time 2, right? We can also think of a 0 coupon bond that matures in 2 years, right? The coupon rate's 0%. The face value is $100, right? This $100 payment, likewise, we can think of as a 0 coupon bond, right? That matures in 2 years with a face value of 100. And this last payment, right, we can think of as a 0 coupon bond, right? Coupon rate equals 0%, matures in 3 years, and its face value is $1,100. Okay. Okay. So here's what I want to illustrate. This coupon bond, right, which throws off this series of payments, 100, 100, 1,100, right, we can think of as the sum of 3 different bonds, 3 different 0 coupon bonds. This 0 coupon bond, this 0 coupon bond, and this 0 coupon bond will end out equaling this coupon bond. Okay? So if we know the price or yield to maturity of this bond, the price or yield to maturity of this bond, and the price or yield to maturity of this 0 coupon bond, we can end out getting the price or yield to maturity of this bond, right? We can figure it out, okay? So this is a useful decomposition. A coupon bond can be decomposed or thought of, right, as a series of 0 coupon bonds, where the 0 coupon bond have maturities at precisely the date of coupon payments of the coupon bond. All right, back to our slides. 0 coupon bonds issued by the U.S. government are called treasury strips. So a treasury strip is a 0 coupon bond, which remember means it only makes one payment, just the payment at maturity. When thinking about how the prices of treasury strips are communicated, how they're quoted as a percentage of that maturity payment. Okay? We're going to see this is quite useful to us because we can use treasury strips, which individually are very simple bonds, to price a more complicated coupon bond, just like we did over in our glassboard work. Okay? So let's take a look at this example. So suppose we're standing in January 2010. Suppose today is January 2010, and we have the following quotations for treasury strips. So for a treasury strip that matures in January 2011, the bid is $99.69, the ask is $99.70. Okay. So how can you think about a bid price? Well, imagine walking up to the treasury dealer. She's bidding $99.69. So that means if you walked up with a $100 treasury strip, she will buy your treasury strip for $99.69. Right? That's the price at which you can sell your $100 treasury strip. Okay. Now, if you had a $1,000 treasury strip, right, she would pay 99.69% of it, right? So that would be $996.90, okay? So you can think about these quotes as a percentage or an amount out of 100, right? Those are equivalent. All right? If you walked up to her and rather than having a treasury strip you want to sell her, you want to buy a treasury strip from her, okay, that is the ask price, right? That's the price at which you can buy. She is asking $99.70 for every $100 strip. So if you want to go and buy a $100 treasury strip from her that matures in January 2011, you got to pay $99.70. If you want to buy one from her that matures in January 2012, you got to pay $96.15. If you want to buy one that matures in January 2013, you got to pay $94.63. Okay. Okay, so that's how the quotation works. Okay. So just to recap, you can buy $100 in January 2011 for $99.70 today. So for every dollar at maturity in January 2011, it should cost 0.9970 today. Okay? For every dollar which matures in January 2012, it would cost 0.9615 today. For every dollar at maturity in January 2013, it would cost 0.9463 today. And so you can see, you can use those conversions, right? 0.997 per dollar that matures in January 2011, 0.9615 per dollar that matures in January 2012, and 0.9463 per dollar which matures in January 2013 to price a coupon bond with annual coupons that are paid in January 2011, then January 2012, and then finally the big lump sum and coupon payments at the end. Okay. So just like we did in our glass board work, right, we can use this set of treasury strip quotations to price a more complicated treasury bond. All right, let's do an example. Suppose it's January 2020 today and use the following strip prices and interest rate to compute the price of a July 2021 maturity, $1,000 par, 4% coupon treasury bond with semi-annual payments. Okay, so quickly in your brain, think about what that information about the coupon bond means about the layout of the cash flows. 4% coupon on a $1,000 par value or face value means $40 will be paid per year. Semi-annual payments means $20, right, every 6 months. Okay? And if it matures in July 2021 and today is January 2020, that's a year and a half out, a maturity of a year and a half. So what we've just been told there is the stream of cash flows will be $20 in 6 months, $20 in a year, and $1,020 in a year and a half. Okay? Try and get good at this. When you read information about a coupon bond, lay out the cash flows in your mind. Okay, assume that there are exactly 1.5 years until maturity and that the next semi-annual payment is in July 2020, right? That's exactly 6 months from today, which is January 2020. The interest rate below is quoted as a semi-annually compounded APR. And so what we're being shown below are treasury strip prices here, right? This is a strip price, this is a strip price, right? Remind yourself what the strip price means. For a treasury strip, which matures in July 2020, for every $100 of face value, it costs you $98.75 today, right? Likewise, for every $100 of face value for a July 2021 strip, it costs you $95.25 today. Yeah. And then finally, for a treasury strip which matures in January 2021, rather than being given a price, we're given a rate, right? This is a yield to maturity. We know there's a one-to-one mapping between prices and yield to maturity, right? You give me a yield to maturity, I can give you a price. You give me a price, I can give you a yield to maturity, right? We know prices can be quoted as either dollars or rates, right? AKA a yield to maturity. Okay, let's jump to Excel and do it. All right, I'm on the next tab. And you can see the information that we just discussed, right? The coupon bond we're considering is a 4% coupon, semi-annual payments, so the payments per year is 2. It matures in 1.5 years. It has a par value or face value of $1,000. Okay. Here's the information on the strips. Okay. The July 2020 strip price, $98.75. The January 2021 strip rate is 3% with semi-annual compounding. Remember what that means. If I give you an APR of 3% with semi-annual compounding, quickly do in your brain, oh, that means the rate is 1.5% every 6 months, right? That's what that means. That's what I'm communicating, or what the bank is communicating to you when it gives you an APR of 3% with semi-annual compounding. All right, and then this July 2021 strip price of $95.25. Remember, that means for every $100 of face value maturing in July 2021, it costs you $95.25 today. Okay, so here is the stream of payments that we just laid out. Remember what this coupon bond promises. The coupon bond promises $20 in 6 months, that would be July 2020. Another $20 in a year, that would be January 2021, and $1,020 in a year and a half, that would be July 2021. So to get the price of this coupon bond, we're going to have to calculate the present value of each of these components. Okay, so let's do it. And what are we going to use to get the present value of each of the components? Consistent with our glass board work earlier, we're going to use the treasury strip information. So let's take the first coupon payment of $20. Right, the first coupon payment of $20, what is its present value? Well, we can use, this arrives in July 2020, we can use the strip price for July 2020 of $98.75. $98.75 means for every $100 of strip value face, it costs $98.75 today. So this $20, all I'm going to do is multiply it by $98.75 over 100. And that tells me this $20, which arrives 6 months from now, costs $19.75 today. Its present value, its price, is $19.75 today. Okay. Likewise, we can do the same thing with the July 2021 payment, the $1,020. Again, we just multiply by the strip price divided by 100. That $1,020 costs $971.55 today, according to the strip price. All right. Now, for the January 2021 cash flow of $20, we're not given a price, we're given a rate. Okay, but that's fine. What do we do with that rate? We take the $20 and we discount it by that rate. So we say 1 plus 3%, but remember it has semi-annual compounding, right? So we're going to divide by 2. Right? Because remember, 3% APR compounded semi-annually just means 1.5% every 6 months. Okay, well, we need to discount back how many 6-month periods are there between now and January 2021? 2, right? 2 6-month periods. So this $20 arriving in January 2021 has a present value of $19.41. All right, sum these together and we get our bond price, the price of our coupon bond, which is $10.1071. And again, is another great illustration of using zero coupon bonds in the treasury environment called treasury strips, the prices and yield to maturity of zero coupon bonds to price the more complicated bond, which is the coupon bond. All right, let's go back to the slides and finish with some practice problems in this topic. Practice problem number 1. Consider an 8% coupon bond with semi-annual coupons, $1,000 face value, and 25 years left until maturity. The next coupon is due in 6 months. If you know that the yield to maturity of the bond is 7%, APR with semi-annual compounding, what must the price of the bond be? Okay, back to Excel. Next tab. So here is the bond information. The coupon rate is 8%. It makes 2 payments per year. It matures in 25 years. The par value is $1,000, and the yield to maturity is 7%. Remember, that's an APR with semi-annual compounding, aka the rate that's being communicated is 3.5% every 6 months, right? All right, let's price the bond. Well, the price of the bond will be the present value of all those coupon payments, those identical coupon payments. There's going to be 50 of them over the next 25 years. Those identical coupon payments plus that big lump sum payment at the end. That's the present value of an annuity with then a big lump sum payment at the end. We know we can find the present value of an annuity, including a lump sum payment at the end, with the PV function. Okay. So we say equals PV. What is the rate? So what is the appropriate discount rate of all of those cash flows? Well, remember, we can think of a yield to maturity as essentially the discount rate which delivers the bond price. Remember, that's what a yield maturity is. It's the discount rate which is implied by the bond price. So there's a one-to-one mapping between bond prices and yield to maturity. Here we're given a yield to maturity. We can use that to discount the cash flows and get the bond price. So let's do that. So the yield to maturity is 7%. Remember, though, it's 7% compounded semi-annually. So it's really 3.5% every 6 months, which is the frequency of the coupon payments, right? Remember, they're every 6 months. All right, the number of periods. In this setting, it's the number of coupon payments. Well, there's 25 years worth of 2 coupon payments per year. So that's 50. Just think of this as there are 50 6-month periods in 25 years, and coupon payments are being made every 6 months. What is the size of those coupon payments? Well, it's the coupon rate of 8% times the par value or face value of 1,000 divided by 2. Or maybe some of you just calculate that quickly. Okay, I know it's $40. Okay. But formulaically, that's how you would arrive at 40. Okay. And then remember that this optional FV, you can think of that in the bond context as the face value, the big lump sum payment at the end. That's 1,000. Okay, close parentheses, and we're going to get the bond price. This bond's price is $1,117.28. Good, let's go back and do the next problem. You notice that the yields to maturity of some 0 coupon treasury bonds are given by this table below. All of the yield to maturities are quoted as APRs with semi-annual compounding. All treasury coupon bonds make semi-annual payments. A says, you are looking at a 2-year 0 coupon treasury bond, face value equals $1,000. What's its price? B says, would the yield to maturity of a 1.5-year 2% coupon treasury bond be more than, less than, or equal to 2%? And why? C says, would the yield to maturity of a 1.5-year 3% coupon treasury bond be more than, less than, or equal to the yield to maturity of a 1.5-year 6% coupon treasury bond? Explain. And D says, what is the current yield of a 1-year 3% coupon treasury bond with a face value of $1,000 and semi-annual payments if its price is $1,012? Is its current yield more than, less than, or equal to its yield to maturity. All right, a lot of questions. Let's attack them over in Excel. I'm on the last tab. All right, and we have the information below. Here is that table of yield to maturities. The 6-month yield to maturity, 2%. The 12-month yield to maturity, 2.5%. The 18-month yield to maturity, 3%. And the 24-month yield to maturity of 3.4% for all of our treasury strips. These are our zero coupon treasury bonds. Remember, all these rates are APRs with semi-annual compounding. So they're compounded twice per year. And the first question is, what is the price of the following treasury bond? A treasury bond that's zero coupon, has a par value of $1,000, and matures in 2 years. So what is the price of that bond? Okay, so this question is asking us to match this bond with its appropriate spot rate, right? With its appropriate spot rate. And which one is that? Well, the bond that matures in 2 years, we're going to use the yield to maturity of the treasury strip, right, which matures in 2 years, right? So that's going to be this 3.4%. Okay? So we essentially have $1,000 arriving 2 years from now, and we need to calculate its present value. We're going to calculate its present value by discounting it by the appropriate rate. The appropriate rate is going to be the yield to maturity of a treasury strip, which matures in 24 months. So take this $1,000 and divide by 1 plus 3.4%. Remember, it's an APR with semi-annual compounding, so we have to divide by 2. This 3.4% rate just means 1.7% every 6 months. Well, we need to, so if it's 1.7% every 6 months, how many 6-month periods are there in 24 months, right? 2 years from now. There are 4. Or formulaically, you can see it as the 2-year maturity of the treasury times the fact there are 2 6-month periods per year. Good. That gives us our $934.79 price of this bond. Okay, good. All right, B says, would the yield to maturity of a 1.5-year, 2% coupon bond be more than, less than, or equal to 2%? Okay, so we could go through the process of calculating the yield to maturity for such a bond, or we can make the following observation. Okay, the individual spot rates for the 3 payments that correspond to this bond. So think about this bond. This bond will make 3 payments, right? In half a year, there will be a coupon payment, right? There'll be some cash flow. In 1 year, there'll be some cash flow. Okay, that'll be a coupon. I'll put CP because it's a coupon payment, but you just think about it as a cash flow. There'll be a coupon here, and then in 1.5 years, there'll be the face value plus the coupon. Okay. All right. Well, the yield to maturity which corresponds to this coupon payment is 2%. The yield to maturity which corresponds to this coupon payment is 2.5%. Okay, the yield to maturity which corresponds to the final coupon payment is 3%, right? Okay. So the yield to maturity of this entire bond, which has these 3 cash flows, is going to be some weighted average of 2%, 2.5%, and 3%. It's going to be some weighted average of those 3 numbers. Remember, that's how you can think about yield to maturity. It's a complicated, right, weighted average of the individual spot rates. Okay? Well, a weighted average of 2, 2.5, and 3% is definitely more than 2%. Right? If I have positive weights on these three numbers, and the weights have to add to 1, right? I have positive weights on these three numbers, and weights add to 1, that's definitely going to be greater than 2. Okay. All right. So we will say more than 2% because the 6-month, 12-month, and 18-month YTMs are all greater than equal to 2%. So some answer like that. Make this bold. Okay, so it's going to be more than 2% because the 6-month, the 12-month, and the 18-month yield to maturities are all greater than or equal to 2%. Good. All right, next question says, would the yield to maturity of a 1.5-year 3% coupon bond be more than, less than, or equal to a 1.5-year 6% coupon bond? Okay. All right. So let's look at a timeline again. Okay. So 2 bonds, 0, 0, 0.5, 0.5. Right, 0.5 is just 6 months, right? 1, 1, 1.5. One and a half. All right. So this bond up here will be the 3%. This bond down here will be the 6% coupon. Okay. All right. So this is the key insight. The difference between the 3% here and the 6% here is going to be the 6% coupon bond is going to have more cash flow. It's going to have more coupon and more coupon payments at the 6-month and the 1-year mark, right? Right? And so when thinking about the yield to maturity being a weighted average of the yield to maturity at each of these 3 dates, the 6% bond is going to have more weight on these, it's going to have more weight on these earlier dates, right? Because more cash is arriving at that date. Okay. All right. So let's look at the yield to maturity for these 3 dates. We have 2%, 2.5%, and 3%. What did we just say? The 6% coupon is going to have more weight in its yield to maturity at the earlier dates, right? Which are smaller rates. So again, let me just repeat. The 6% coupon bond is going to place more weight on these earlier yield to maturities. Okay? Again, the overall yield to maturity you can think of as just a weighted average of the yield to maturity or spot rates at these 3 individual times. The 6% coupon, because it has more cash flow arriving at earlier times, is going to have more weight on these earlier dates, which means its weighted average yield to maturity, the yield to maturity for the 6% coupon bond will be lower than that of the 3% bond. Or said another way, the 3% bond yield to maturity will be greater than that of the 6%. So let's write something like that. So would the yield to maturity of the 1.5-year 3% coupon bond be more than, less than, or equal to the 1.5-year 6% coupon? The 3% coupon bond will be greater because, so the 3% coupon bond will have more weight at later periods which have higher yield to maturity. So something like that. Or you could say greater because the 6% coupon bond will have more weight at earlier periods which have lower yield to maturity. Okay. That's communicating the same thing. Okay, so some answer like that. Good. All right, last question. So we're given the following bond. It has a coupon rate of 3%, matures in 1 year, has a par value of 1,000, and the bond price is 1,012. Okay. And we're asked first to calculate the current yield. So remind yourself what the current yield is. This is just a definition. Okay. The current yield is the cash flow you're going to receive in the next year. That goes in the numerator. And then in the denominator goes the bond price. So what's the total amount of cash flow we're going to receive in the next year coming from the coupon payments? Okay, so that's 3% times the 1,000, okay, divided by the bond price. So this current yield is 2.96%. Okay, 2.96%. Okay. Will the current yield be greater or less than the yield to maturity? Well, the current yield is 2.96%. Okay. This bond matures in 1 year. Let's go up and look at the yield to maturity of the 6-month Treasury strip and the 12-month Treasury strip. Do you see the 6-month Treasury strip is 2%, the 12-month is 2.5%. That means this bond's yield to maturity will be a weighted average of these two numbers. Okay. So will the current yield be greater or less than the yield to maturity? It will be greater because the yield to maturity will be a weighted average of 2% and 2.5%. Okay, so you communicate something like that. You know this bond's yield to maturity, right, will be a weighted average of these two numbers, 2% and 2.5%. The yield to maturity of the 6-month strip and the yield to maturity of the 12-month strip. Because this coupon bond has cash flows arriving at both times, it's going to be a weighted average of those two numbers. Well, something in between 2 and 2.5%, okay, is going to be less than this 2.96%. So this current yield will be greater. This 2.96% will be indeed greater. Good. Back to our slides. And that's it. So what have we done in this topic? We've introduced bonds. I can imagine you perhaps wanting to watch the video again because there's just a lot of institutional detail to get down. You know, what is a face value? What is a maturity date? What is a zero coupon bond? What is a yield to maturity? What is a term structure of interest rates? What is a spot rate? Et cetera, et cetera. There's just a lot of institutional detail to know, so it might be worth watching the video again. But sort of stepping back big picture, what I want you to take away is that we can use the same present value, future value framework that we've developed in prior videos to price bonds.